Welcome to Part 2 of Competency 1 quiz. In this video, we will continue to work with properties of real numbers. Number 6, which of the following is undefined? Undefined generally means that you're going to take some value and divide by 0, okay? So that's going to involve division. Well, right off we see A is not an option because it's multiplying. B, we do have division. However, if we take 0 and divide it by 12, that'll be 0. Okay, so this is going to be undefined. Okay, but if I have 0 divided by x, that's going to equal 0. Okay, you just have to know the properties. Okay, so C will not work. B isn't going to work. C is addition, so can't use that. D obviously will be what we need. So let's actually put that these values in the calculator and see what happens. Okay, so x divided by 12 gives me 0. But if I say 12 divided by 0, I get this error. It says divide by 0. Attempted calculation contains division by 0. Calculation fails. And that means it is undefined. Okay? All right, let's go to number 7. How is the expression the property of w and x subtracted by y written algebraically? Okay, so product, okay, it says the product. I hope I said product earlier. Anyway, product means multiply, and they want to put these two guys together, and then we have subtraction by the y. So what does this mean? We have product w times x minus the y. Now, we could just write the w and x together because that implies multiplication, and then subtract the y, and that would only be option A. Okay, and if you put in numbers for each of these, you could actually see how the values would come out differently to test it. Okay, anyway, that is what they are implying. Well, obviously B is not going to work because they have y first. They say it's subtracted by y, not subtracted from y. So the English doesn't match B. And then they didn't say w minus or w subtracted by y. That's not what they said, because the x is by the word subtraction, so that doesn't work. And then D, here they have x subtracted by y. Well, that doesn't make sense because D, what it's saying is w times, okay, w times x minus y. The English is not the same, so D does not work. All right, number 8. John is about to evaluate the expression -4 times 6 plus 9. He decides to use the distributive property of multiplication over addition. Okay, which one of the following illustrates this approach? Okay, what does that mean? It means that we are going to multiply in -4 to each of the values inside the parentheses. Okay, so we're going to take -4 multiplied into 6, and then we're going to multiply it into 9. Okay, well, A does not do that. B, it just switches the position of 6 and 9. That doesn't make sense. So B, that's not an option. Now, the way C is saying to multiply -4 times 6, then add 9. No, that doesn't make sense. Well, it's not what we're seeing anyway, and it's not distribution, okay? Now, D does. Notice, -4 is multiplied to 6 first, and then negative 4 is multiplied to 9. And that is what we intended. We're going to distribute it into each number, and we've done that. So that would be option D. All right, let's move on. Number 9, Mary is asked to simplify the expression negative 2/5 to the negative third power. Okay, then it says she wants to first change the expression so that it has a positive exponent. Which of the following expressions should she evaluate in order to arrive at the correct answer? Okay, what they're talking about is this particular property. They're talking about this property. Let's say I have 2 to the negative third. That is actually equal to 1 over 2 to the third. Okay, so if you're not familiar with this particular property, look it up. That is negative powers. There's a lot to be said about them. But let's put in the calculator and compare what we get. Okay, I already know what we get. I can see it. You may already see it also. Okay, so we need to carrot up negative 3, push enter. Okay, now that gives you a decimal answer. Okay, so to get it into a fraction, push math. We want number 1 right here. It's already highlighted. Push enter, enter again. That's 1/8. Okay, now we want to put, that was the left side. Now we want to do the right side. So this is what we're going to do. We're going to push alpha, y equals, number 1 is already highlighted. We want that. Now we need 1, arrow down, put in your 2, carrot up, number 3. Okay, now I'm going to arrow over for a second, see what I did. All right, now push equal. It's also 1/8. Now, if you weren't sure what I was pushing, stop the video, rewind, do it for yourself on your calculator and see what the result is. But they do equal 1/8, so they're equivalent. Now, this property can also be written generally like this: a to the negative n, or, oh, you could use any variable you want, equals 1 over x to the n. Okay? Same thing. All right, so what happens here? Option A is out because all they did was take the negative off of the exponent, and that's not valid at all. Okay? Let's look at B. Okay, B has 1 as the numerator. I agree with that. And in the parentheses, they didn't change anything. I like that. That's perfect. No changes to the base. And the exponent has the negative taken off, which is legal. I'm feeling option B. I'm liking it. Well, let's see what happens with C. Uh-oh. They changed our base from a negative to a positive. Can't do that. All right, so that option is a goner. All right, now, option D. Oh, it's very subtle what they did, and I don't like their tricks. They changed the base to the reciprocal. They used 2/2 instead of 2/5. That's a dirty trick. D is not our option. It's B. Okay. That wasn't very nice of them. All right. Number 10. Consider the following list of 6 numbers. Okay. And they list out all the numbers we're supposed to look at. Now be careful. They're all kind of smushed in almost. Pay attention to these commas. See them? It's separating each of our numbers, okay? All right, so be careful with those guys. When you're taking the test, you might want to draw like little pencil lines between them so you see them separately, okay? And it says how many of these are rational. Rational means they're a whole number, they're an integer, they terminate, the decimals terminate, or the decimals repeat. Okay, so let's take a look here. It says rational, so they have to do those things. Negative 3 over 19. All right, here, I'm going to clear this out. So let's start putting these numbers in. If it's negative or positive, it's irrelevant. We don't care about that. We're caring about, are they whole numbers? Are they integers? All those things I said. Positive or negative is totally irrelevant. Okay, so let's look at 3 divided by 19. What happens here? That looks like it's not repeating. It looks like it goes on forever. For this situation, if I were you, I would pop that into Desmos or Wolfram Alpha to double check that. But I'm not thinking right offhand, I would say that is irrational. Okay. Regardless, let's try another one. Okay. The next number, the cube root of 64. Yeah. Well, let's give it a try. I'm saying it's a whole number, but let's prove it to ourselves. Okay. So let's say alpha window. We need number 6. Okay. Pop in your 3, arrow over 64, push enter. Ah, I was right, whole number. So that one's in the count. Now let's look at the next number. That is a decimal that repeats 515151. So that is repeating. So that one we count as rational. This one here, that's irrational because it's like this increasing pattern that goes on forever. It doesn't stop and it doesn't honestly repeat. So can't count that one. This is terminating. So we have to count that one. All right, now let's look at the next one. So let's pop that last one into the calculator. So second square root. Now I want the fraction set up. So alpha y equals, number one's what we want. So 16, arrow down, 9. Now let's push enter. And that is 4 over 3. That's going to be repeating because of the denominator. So, but let's go ahead and turn that into a decimal. So how do we do that? So math, and we want number 2. You can arrow down or just push number 2. I arrowed down, so now I push enter, enter again. Well, that's a repeating 3. Okay, so that's 3 bars. So that is rational. So that goes on our list. Now, okay, first glance, you would say, okay, 1, 2, 3, 4. There's a glitch. Actually, the very first one. That is also going to be on our list of rationals, and I want to tell you why. Any number that has a denominator, any fraction with a denominator of 19 will be repeating, okay? So anything in this form, okay, is going to have a repeating decimal. Okay, you can put any value of x in, okay? And in particular, be wary of anything over 9. Any number over 9. Okay, and what that's going to equal is this. Put numbers in the calculator and play with it, and you'll see. So before I move on and actually kind of play with that, let's look at how many we have. 1, 2, 3, 4, 5. Because it said how many of these are rational? Well, D is your answer. That would be 5. So let's go back to this first one and say 3 divided by 19. Push enter. That is not a fair value to give you unless you know this property, because the calculator doesn't even give us enough numbers to see the repeating value. You need a few more, and then it'll start over with 1, and then this long list of numbers is what actually repeats. Put it in Wolfram Alpha or an online calculator, something that will show you all of the decimal. And to be honest with you, I think Wolfram Alpha right now, at this point, is the only one that gives you that vast number of decimals. So it's probably your best bet. I did it and I showed it to myself just to see how the property works again. I had been told that years ago, but years ago, we didn't have these computers that showed us all these decimal points, okay? All right, so now let's do something else. Let's do something over 9, okay? So I'm going to say alpha y equals number 1. So let's say 4, arrow down, and 9, push enter. Okay, but we want the decimal, okay? So let's do this. Math, number 2, and enter. It's 4 repeating. So like I said, any number over 9 is going to be that number repeating. So let's push 5. Let's just do division this time. 5 divided by 9. Push enter. 5 repeating. And you can put in other numbers to see this. So those are 2 properties that you need to remember, and they're just handy to know, and they come up a lot. Okay? All right, this is the last question in the Competency 1 quiz. Thank you guys for watching, and I have the full set of competencies on my YouTube channel. Thank you guys who have already been watching. I kind of did them backwards, so now it's a full set. I will add to this, and I will add other things. I have a few domain quizzes out there that are in Google form. I'm going to add that. So look for more coming up, as well as other exam prep help. It will all be free. I will not charge you for anything, especially if you guys keep watching and liking. Very sweet comments from some people. I truly appreciate it. It helps me keep going. Thank you, and thank you for subscribing. And again, guys, I wish you the best and happy testing.